how can it be that the universe not only was very special, but it was very special in a very special way? That is to say, it's only in that gravity was somehow not activated in the very early universe.
The current view is that the universe began with a colossal event known as the Big Bang. Right after that, an inflationary period followed, which caused an exponential expansion spanning a staggering 93 billion light-years across. However, that's just the observable part of the universe. There could be an infinite amount more, stretching beyond our current observations, shrouded in mystery. But fear not, we have the James Webb Space Telescope, along with the brilliant minds of thinkers like Roger Penrose, pushing the boundaries of our understanding of the vast and incredible universe. So, let's dive into the mind-boggling wonders that await us. The observable universe is undeniably massive. It's like a gigantic bubble around us, reaching as far as light could have traveled since the beginning of the universe, approximately 13.8 billion years ago. If something is so far away that its light would have taken more than 13.8 billion years to reach us, we simply can't see it because the universe hasn't existed long enough for that light to reach us. This observable bubble extends about 46 billion light-years in any direction from our vantage point. But why is it larger than the universe's age? Well, the universe has been expanding since its birth, moving things that emitted light 13.8 billion years ago even further away. This expansion has led to an observable universe that's an immense 93 billion light-years across. And keep in mind, this is just what we can see. There's potentially much more beyond our current grasp. Our observable universe is teeming with activity. It's home to at least 2 trillion galaxies, each containing billions or even trillions of stars, planets, and other celestial objects. Beyond what we can see, there are mysteries like dark matter, a substance we can't observe directly but know exists due to the way galaxies move, and dark energy, responsible for the universe's accelerated expansion. Among the wonders, we find the cosmic microwave background, a faint glow of radiation echoing the Big Bang's event, and the elusive neutrinos, nearly undetectable particles racing through space. The ever-expanding universe brings about a fascinating spectacle. However, we're watching everything on a delay. The light we see from distant stars and galaxies left them eons ago, allowing us to glimpse into the past, revealing the universe's evolution. To understand the vastness of the universe, let's take a closer look at the Sun and the Moon. Though they may appear close, the Sun is a staggering 150 million kilometers away, approximately 93 million miles. However, this distance is not constant. Earth's orbit around the Sun is elliptical, so the distance changes throughout the year. When closest to the Sun, known as perihelion, we're about 147 million kilometers away. In contrast, at aphelion, the farthest point in our orbit, we're about 152 million kilometers away. Now turning our gaze to the Moon, it's about 384,000 kilometers or 238,000 miles away from Earth, and its distance from us also changes during its elliptical orbit. At perigee, the closest point, it's about 363,000 kilometers away, and at apogee, the farthest point, it's around 405,000 kilometers away. If we could travel at the speed of light, it would take us around 8 minutes to reach the Sun and only 1.3 seconds to reach the Moon. But if we could only travel at the speed of sound, it would take about 14 years to reach the Sun and roughly 10 days to reach the Moon. While our Sun and Moon might seem relatively close in the grand scheme of things, our nearest stellar neighbor, Proxima Centauri, is much farther away, residing approximately 4.25 light-years from Earth. A light-year is the distance light travels in a year, so when we observe Proxima Centauri through a telescope, we see it as it was 4.25 years ago. Fascinatingly, this star has at least 2 known planets, with one potentially residing in the habitable zone, offering a glimmer of hope for finding extraterrestrial life. The Alpha Centauri system is home to 2 more stars, Alpha Centauri A and B, situated about 4.37 light-years away from us. As we venture out further, we encounter the Milky Way, our own galaxy. The Milky Way is a massive spiral galaxy, stretching between 100,000 and 200,000 light-years across and tens of thousands of light-years thick, especially towards the center, where a bulge approximately 12,000 light-years across resides. Our solar system is situated about 26,000 light-years away from the center, in an area called the Orion Arm. The Milky Way is home to a staggering number of stars, ranging between 100 and 400 billion, each with its planets. Yet, it's essential to note that our view is limited. On a clear night, far away from city lights, we can observe around 3,000 stars with the naked eye. Zooming out, we realize that the Milky Way is not alone. It's part of a larger structure known as the Local Group, containing over 20 other galaxies. The Local Group spans approximately 10 million light-years across and is like a bustling metropolis of galaxies. Among its members are the Andromeda Galaxy and Triangulum Galaxy. In fact, the Andromeda Galaxy is the closest major galaxy to the Milky Way, located about 2.5 million light-years away. Beyond the Local Group, we find the Virgo Supercluster, a vast collection of over 100 galaxy groups and clusters spanning approximately 110 million light-years across and weighing an astonishing 1,480 trillion times the mass of our Sun. The Virgo Supercluster is not an isolated entity. It's just one among countless other superclusters that make up the observable universe. Another awe-inspiring supercluster is Laniakea, stretching about 520 million light-years across and encompassing the Local Group and numerous other galaxies. In fact, Laniakea is part of an even larger structure called the Pisces-Cetus Supercluster Complex. This intricate web of galaxies intertwines through the universe, offering a glimpse into the vastness of creation. These observations and structures have led some to theorize about the cyclic nature of the universe. Roger Penrose, a renowned theoretical physicist, has proposed the intriguing idea of conformal cyclic cosmology, or CC. According to this model, the universe goes through endless cycles, with each phase beginning with a Big Bang and expanding infinitely. At the end of each cycle, the universe collapses, only to be reborn anew in the next cycle, creating a perpetual cosmic Groundhog Day. CCC presents an idea that could have significant implications for our understanding of the universe's structure and the enigmatic phenomena like dark matter and dark energy. In particular, CCC suggests that evidence of past cosmic cycles might be the idea of conformal cyclic cosmology. CCC, proposed by Roger Penrose, opens up intriguing possibilities for understanding the universe's cyclic nature. CCC envisions a series of endless cycles, with each cycle starting with a Big Bang and expanding infinitely, only to transition seamlessly into the next cycle. The concept relies on conformal rescaling to join the end of one cycle with the beginning of another. However, for this to work, all particles with mass, including protons and electrons, must disappear at the end of each cycle. The concept relies on conformal rescaling to join the end of one cycle with the beginning of another. However, for this to work, all particles with mass, including protons and electrons, must disappear at the end of each cycle. This aspect of the theory remains speculative, as we have not observed particles decaying in this manner. One fascinating implication of CCC is the distinction between bosons and fermions. Bosons, such as photons, behave the same way regardless of the universe's stretching or squashing, allowing them to transition from one cycle to the next with ease. In contrast, fermions, like electrons, do not make this journey and remain confined to their respective cycles. According to Penrose, this may offer a potential resolution to the black hole information paradox, as fermions falling into black holes are converted into radiation, which is composed of bosons. As of our current observations and understanding, the universe appears flat and is dominated by dark energy, which drives the universe's accelerating expansion. This indicates that the universe might be infinite and will continue to expand indefinitely, setting the stage for future cosmic cycles. Within CCC, we find ourselves somewhere in the middle of a cycle, hurtling toward an infinite future of eternal expansion, only to pave the way for the next cycle's beginning. In order to provide evidence for CCC, scientists are turning to the cosmic microwave background, CMB, the afterglow of the universe's birth. CCC predicts that the CMB may contain clues about events from previous cosmic cycles, such as temperature circles caused by the collision of massive black holes from the previous cycle, creating gravitational waves that ripple through space-time. The James Webb Space Telescope, JWST, with its exceptional ability to observe the CMB in high detail, could play a crucial role in uncovering these potential clues. Moreover, JWST could help address a current cosmological puzzle concerning the size and expansion rate of the universe, known as the Hubble constant. By observing standard candles, objects with known intrinsic brightness, JWST can determine their distance and refine our understanding of the Hubble constant. Additionally, JWST's ability to observe in the infrared spectrum enables it to use gravitational lensing and cosmic chronometers to calculate distances and measure the universe's expansion more precisely. In conclusion, CEC offers a thought-provoking perspective on the cyclical nature of the universe. While some aspects of the theory remain speculative, the James Webb Space Telescope may provide valuable insights into the universe's history and growth, helping us further comprehend the vast mysteries that lie beyond. Don't forget to subscribe to our channel AstroVentures for more mind-bending videos on the mysteries of the universe.